Hello everyone, I hope you're liking our videos. Now in that same sequence, this is the video where we are looking at a reaction, how to get phenol using cumene. So the compound which is in front of us is cumene. Actually, how can you form this compound? You can take help of Friedel-Crafts reaction. So Friedel-Crafts alkylation process. So in that process, we can take benzene, and on benzene we can attack CH3, CH2, CH2Cl in presence of AlCl3. That's option 1. The same thing can be attained if you attack benzene with CH3, CHCl, CH3, again in the presence of AlCl3. So eventually both of these things will give you same answer, which is cumene, and the compound which is written here is cumene. On this cumene, you are attacking oxygen. So oxygen shows a kind of insertion. I'm drawing oxygen as O double bond O. So it shows an insertion on CH bond. So you can observe this CH bond. This is a very important thing here. So in the CH bond, we can observe that this particular CH bond, which is marked here, this gets presence of oxygen. So due to this, what we can get here, we can get a ring which is drawn earlier. On this carbon, we can put these two CH3s, and this O is inserted here. So it takes formation of a hydroperoxide. Now this hydroperoxide, as you can see here, is named because this is a peroxide linkage. One side is hydrogen and one side is cumene. So the name for this compound can be given as cumene hydroperoxide. Now later, cumene hydroperoxide, which we have drawn here, is being reacted with H+. So see what is going to happen when any saturation is given. You have these oxygens. So we can utilize these oxygens first to protonate. In this protonation process, it will become ring, and on this position we have CH3, 2 units, and it is OOH, and this one more H, and there's a plus charge here with 2 electrons. After getting all these things, can I say water can be a leaving group here? But for that, it is waiting for some migration. We have option to migrate CH3, that's 1. Other option is we have pH. So when you compare migratory aptitude of pH and CH3, the sequence is hydride is better than pH is better than C with more groups of CH3s, as in 3 CH3s, is better than C with C is given with the 2 CH3 units with 1 hydrogen, is better than C is having 1 unit of hydrogen, 2 units of hydrogen and 1 CH3, is better than C is having only H3. So we understand very clearly that in this sequence, the group which is going to migrate is pH group, and in this process, if this migration happens, if you observe, we have drawn a ring. On this ring we have drawn 1 carbon, 1 CH3 here, and this is also CH3. This was O and this is OH plus. Migration of pH from here to here will ensure removal of this water, and in this process, since water comes out, we can get CH3, oxygen getting attachment of this group, which is pH. Plus charge appears on carbon. So why it is good that to have plus charge on carbon as compared to oxygen? The reason is oxygen, being more electronegative element, will not allow plus charge to be on it. The water which we have written here will come back, attack on it. This time it will attack on carbon. After this attack, we can expect these CH3s at this place, OH2 plus. Remember, whenever oxygen forms 3 bond, you can show it directly O plus. That's a simple thing. Followed by this, we can say H plus, which is being taken as a catalytic amount, will be given back. and we get formation of OH on the carbon CH3, oxygen, and the ring. In the last step, this oxygen facilitates removal of a migratory group PHO minus. In this process, the PHO minus which is coming out will grab the hydrogen, because when you talk about this structure which is having oxygen double bond plus hydrogen, in this structure we have two CH3s. So this PHO minus can grab this hydrogen and give us acetone. So end product of this reaction is acetone, along with, for which we are doing this reaction, phenol. Now let me ask one question here. What is the value of pKa of phenol? Or basically I'm asking a question, how can you compare this in terms of its acidity with water? So we compare water and phenol. The pK value of phenol is close to range of 9 to 10. And if you talk about some substituted phenol, these values can change from 9 to, they can be even lesser. Okay, so the meaning of lesser as in they can go to a better, or we can say more and more acidic behavior. But when you compare the water pK is 15.74. So this tells us clearly that phenol is more acidic as compared to water. I hope you like this reaction.